Okay, hello everybody. My name is Paul Taylor. I'm going to, over the next 20 minutes, talk to you about big data and some of the challenges that you would have when looking at big data. Before we dive into the detail of the presentation, just give a few moments, a little bit of background to myself. I've been a consultant implementing change across a number of industries for 30 years. I also do a large amount of speaking and writing on a number of subjects, change, freelancing, technology, including big data. I've published a number of books around change management and contracted. I run a number of non-execs for some social enterprises, do some mentoring. I'm a lecturer for the Open University, and I'm trying to very slowly complete a PhD at the Middlesex Business School. So big data, I mean, I think you could probably look at any book or look at any technology article, and big data appears to be everywhere. It's a very, very, very prominent phrase at the moment. I mean, from my point of view, it's got some fantastic uses. I mean, its uses are actually quite wide and vast, and it has provided some real benefits to society. I mean, the modern diseases, which is obviously at the time of speaking, which is the middle of February, 2021, where the COVID-19 pandemic is still bouncing around the UK. You know, I know from speaking and reading articles on the press that big data is being used to try and model that. In the US, there's a number of cases where it's been used to predict crime, and I know large people use sort of big data techniques to try and play or beat the financial markets. But I think while big data has a large number of very good points, and I don't want to be critical of it, but I think one has to be aware that it's not a silver bullet to all the world's problems. I think a number of areas that the phrase is often misused, and even the simple data analysis that's done is often incorrectly branded as big data. And secondly, managing big data projects is a challenging process. It's not something that should be undertaken without a lot of foresight and thought. So the bottom line is why big data is good. If it is implemented or managed poorly, then it will actually cause more problems than it solves. And obviously, over the next 20 or so minutes, I will cover this in a bit more detail. So there's 5 main parts I'd like to discuss as part of this broadcast. The first area, I want to walk through a definition of what big data is to try and avoid any confusion. We'll then look at some of the benefits and uses of big data. The third item, we will look at what are the problems with big data and come up with some ideas on how they can be managed. The fourth area is I've called the dark side of big data. A number of you have probably read articles about how data is being used to manipulate people's behaviours, maybe not to your worth, but to somebody else's worth. Again, we'll just talk through with that, and then we'll just look at the future going forward. So if we just start on the first item, what exactly is big data? If you were to Google or Yahoo or other comparable search engines, the phrase big data, you would receive thousands, hundreds of thousands, if not, of different definitions. But I think it's fair to say there are 3 main trends or themes that appear to be common. One is around the volume of the data, and it's a massive amount of volume, hence the name big. While you can argue the size and volume is relative to your circumstances or the piece of work you're doing, we are talking in the range of millions and millions, if not billions, of data items. And each of these data items will have hundreds of variables within them. So we're talking an absolute humongous amount of data. As well as a large amount of data, the actual data population itself is constantly changing, often at a rapid pace, which basically means in layman's terms, new items are being added, existing items are either being updated or removed quickly. I mean, a prime example could be if you are using a social media platform to model people's responses, as comments and likes are being processed against a particular article, that data set is changing dramatically. And the third area, which is often, I feel, most forgotten actually, is the data itself, as well as being a large amount of data, constantly changing. The actual data itself is stored across a number of different, or a variety of different formats. These will cover what I call traditional predefined structured database formats, for SQL databases, relational databases, for those of a certain age, sequential index files. It's a very structured data. But I think as you go forward in the world now, you get in much more unstructured data formats, which are becoming more and more prominent. And to do proper data analysis using big data, you do actually need to sort of make sure they're catered for. And these will cover things like, videos, audio recordings, free format text, which you've got to try and analyze, images or pictures, social media comments, and many other things. And therefore, if you think about the volume of the data, in fact, it's constantly changing in different formats. Once you've got all this data collected, obviously, this is where the phrase big data comes in, then it's possible to perform a wide range of different types of analysis over that data. I mean, one of the most common analysis people tend to do is, they call it trend analysis or pattern analysis, is where you look at some themes or some patterns through the data to see if there's any correlation or link between the variables. I mean, for example, you might want to do if you're trying to design a website to do online selling, you may want to try and find out, are there particular times of the day that people buy and sell? Are there particular routes through the website that people use to buy and sell? Are there particular routes that people don't want to use? So that sort of stuff you can actually do. I mean, then once you've got this sort of pattern analysis type area, you can use it to do two things really. One is you can get it to explain historical behaviors, like i.e. why did certain products not sell on the website or not sell through the shops. But also you can actually use this data to try and predict behaviors and also shape human future behaviors. Because if you know how way things work or how things are linked together, you can actually look to change people's behaviors. And while that's obviously good in some ways, because it may stop people getting certain amounts of illnesses and other horrible things, it's where I come onto the dark side a bit later. You can talk about people can actually get people trying to manipulate people's behaviour for their own points of view. So let's just go on to, before we get into the dark side and the issues, let's have a quick look at what the benefits and the uses of big data are. I've listed some are here, and these aren't obviously not an exhaustive list, but if you can think of the top four as one type of group and the bottom one on its own. So the top four talk about some sort of like very big type projects. Governments can oft use big data to gather understanding in the healthcare arrangements. They can work out, what type of people have suffered, what diseases, which areas or which parts of the country or states of America, if depending where you are suspect to certain diseases. Same way, meteorologists can actually use big data to try and predict and understand weather conditions. And obviously, that's very good if you're flying an aeroplane or you're on a boat or you're looking to go and watch some cricket. You can sort of like get some ideas and predict what the weather's going to be, so you can take preventative action. Political parties use big data techniques to try and understand voting intentions. Again, there are a number of documented stories that people use sort of these techniques to try and change people's votings. And the fourth item there is medics will often use big data to try and predict the spread and cause of diseases to allow preventative measures to be implemented. At the moment, this is a very topical, at the time of speaking, COVID-19s are still rife over the United Kingdom. Well, if you can look at those four items at the top, they're really like very big type things that you need data to do, strategic type things. But you can use big data for much more than normal functions of the business. For example, cost and profit management. I've worked at places, retail, oil companies and other companies who actually use big data to try and predict, when was the best time to sell petrol and stuff like that, what people bought. So they can work out what their cost and profit is. Marketing and product management, you can understand why people bought and sold products, so you can actually try and analyze and repredict them going forward. Improving the client's experience, there must be hundreds and hundreds of case studies where people have used big data to try and understand how people use different websites to make them as usable as possible. And there's a good old-fashioned internal process efficiencies where, again, I've worked with firms who've done a lot of analysis on how they operate internally, executing trades and other client service activities to try and understand how they can actually improve the client efficiency. So there's a large number of very good benefits that big data can bring. But I think before we get into to take a maybe more the other side of the coin, we probably need to look at some of the problems with big data. And as part of this, I've hopefully come up with some ideas on how some of these issues can be addressed or managed anyway. I think as I mentioned before that big data is not a silver bullet. And therefore, if you do not implement or design a big data project or an implementation correctly, it'll actually cause more problems than it actually can solve. So I think the key point before you dive into the deep end, looking at big data and collecting data and all these fantastic analysis tools, I think the first thing is you really have to have, I call it a clear business reason, which is a polite way of saying you really want to know why you're using the big data, why you're gathering the data, what sort of outputs you want to get out of it. Yeah, and this really should be linked to your organizational strategy. Reason for that is if it's linked to the organizational strategy and it's a clear reason, then it's more likely that senior management will understand it and they will give you a buy-in, and it'll also ensure they will support any changes. Therefore, it sort of leads on naturally that some sort of business case or cost benefit analysis needs to be understood or developed, to be more precise, to show that the benefits of doing the big data project or implementation outweigh the cost and the stress and the challenges of actual implementation. So being a bit more specific, I think the first problem with big data is that the term's often misunderstood and misused. When you get to my advanced years, you can easily become very, very skeptical. But there are a number of firms I've worked with who often will sell you big data consultancy, big data technology. And when you look at it, it's just no more than sort of simple data analysis techniques, simple reporting, simple data extracts. And again, being an old person and very skeptical, you wonder if they're just using the term big data because it's much more easier and trendy to sell. So therefore, the rule of thumb is if you're looking to do a big data project, make sure you're actually looking to do big data. The second area relates to the sheer challenge of processing millions and millions, if not billions, of data items, each with a large number of attributes within it. Bear in mind the additional complexity that the data is constantly changing in, across multiple formats. The bottom line is that you will need a complex, which is a very polite way of saying very expensive technology stack to ensure that all the data is being gathered, it's being linked together, it's being analysed, and this is, and you need very technical skills to do that. So therefore, again, before any firm dives into a big data project, you probably need to really understand the costs and the overheads and the complexity of this technology. And if you can remember a couple of slides ago, this should be covered in the cost-benefit analysis, which I mentioned now. Another area which is actually slightly changed, and changed not in a good way, actually relates to data security. Every country we've spoken to has a data security or a policy on retaining data, ensuring that data is retained for a real reason and only as long as you need it. For those who can remember, there was a GDPR implementation about 2 years ago. No doubt with the UK outside the EU, there's going to be a UK dialect to GDPR. So this is a massively complicated area and it needs to be looked after. Therefore, if you can bear in mind that you could be gathering data across multiple legal jurisdictions, the data could be changing constantly across multiple jurisdictions and in different formats across multiple jurisdictions. Therefore, as well as being related to being impacted by your local data protection laws, you can be impacted by multiple different legislations. So therefore, when you design and build a big data infrastructure, you probably need to ensure it complies with a large number of data security regulation, which is by no stretch of the imagination easy. There are also a certain amount of lack of skilled individuals. I think, again, while big data has been around for a while, it's still relatively new technology or a very new concept. So I think there is, from my experience, a lack of skilled people with general big data skills. There are many people who will pass themselves off as data scientists, data miners, or data specialists, who are clearly not that. They are maybe very good report writers, or somebody who can write some nice SQL statements. But big data is much bigger than that. I mean, the tools you require to do patterns and analysis is massively complicated. So therefore, when you are recruiting, full-time employees, contractors, consultants, vendors to do big data analysis, make sure you really understand what skills are actually offering, as opposed to somebody who's rebadged themselves as an expert when they're clearly not. And the next area is the risk of inaccurate data. And this doesn't actually, not particularly always linked to big data. This applies to any data analysis or any research or any sort of data gathering you do. Bear in mind that big data could have multiple sources of data. Therefore, it may not be possible to link data sources together in a very succinct and tight way. Therefore, you could have some data coupling, which would make some of the analysis a little bit more unreliable. The data itself you gather could be of a poor quality. You could have data gaps missing. It could be out of date, and it could be just completely wrong as well. There could be errors in it. I mean, that happens all the time. The data itself may be over a poor sample size, which would have some sort of bias. For example, if you wanted to do an analysis of online shopping, you may want to get a mix between different genders, different age groups, different locations to try and get some sort of bias. But you may end up only getting females from the west of England, which basically means you don't get a representative sample of the whole of the UK. And the last item is really, and this is more common than you think, is even if all the data is linked together, it's a good quality and it's a good sample size, the data managers could actually the data assessors, to be more precise, could actually generally misunderstand the data. Just get the wrong end of the stick, and that's obviously always a problem. And bear in mind, all these problems will all be exaggerated because you're talking millions and millions of records with hundreds of attributes under each record. So you can imagine a lot more worse problems. So again, these are almost like a byproduct of doing big data products. You can't mitigate these away completely, but what you have to be very clear for is that you really understand where, if you have problems with the accuracy of the data, that this is clearly documented, this is clearly stated. So I mean, even with disclaimers if necessary, produced against any of the analysis or patterns that come out. And moving on to a similar sort of area, but even while you may have the data is completely accurate, you're 100% happy, you're quite happy to sign your mortgage against it, it's completely accurate, you still could have problems actually analysing the data. I mean, for example, there's various off-the-shelf algorithms. There's all various tools you can buy from various vendors who can do some data analysis and look for patterns. There could be problems with those algorithms, so while the data is accurate, the algorithm to do the checking is wrong. And therefore, it means the outputs could either be wrong or misinterpreted or have gaps in them. Again, the size of the volume of the big data doesn't actually hinder that. It makes everything worse. So therefore, I mean, the only real mitigation, and from my experience, is that you will run a number of different algorithms over the data to try and do your analysis. And that could be different ways. So say, for example, you want to try and do some patterns across a correlation between different variables. You might run 5 or 6 different algorithms that do something roughly the same, but do them in different ways to try and look at the data in different angles. Other ways I've done it is where you actually run it on different subsets of the data and try different subsets of the data to try and work it. I think the key thing is that you really need to look at the data in different angles or through different lenses. Also, in the same sort of way, any material issues that you have or within assessment of the data need to be clearly stated up front. So therefore, we've sort of covered what big data is. We've covered what the benefits and the uses are. We've also looked at some of the problems and how these can be managed. Can't be completely mitigated, but they can be managed. So maybe go a bit deeper now into the dark side of big data. As I mentioned earlier on, if you're very clever and you're very good and you've got good data and your algorithms are very, very good, big data techniques allow one to predict and change people's behaviors. This isn't always a bad thing because it could stop diseases or prevention of diseases, and it could also make the traffic patterns run better and public transport run better. But there are a number of well-documented studies or case studies of where big data has been used to try and manipulate people to change their behaviours for somebody else's benefit. Voting intention is a very key one that sort of bounces around, comes back every so often and disappears. So therefore, while changing people's behaviours is a good thing, sometimes it can actually be misused for abuse. So therefore, let's look forward to the future of big data. Big data is here to stay. And I know I've given a number of areas where there's problems and areas need to be marked on, but you can argue any technology has these problems. It's no different from anything else. I think as technology progresses and data capabilities and algorithms and the technology and the understanding of how to improve big data improves, you can almost argue that big data will become the norm. I remember years ago when I started out back in the 80s, processing thousands of records was a time-consuming process. But nowadays this is the norm now, and everything's has been fine, and big data is going to be the norm. But I think also it's important that one does not underestimate the changes involved. Understanding what big data is, look at the implementation issues, and also to understand the dark side. So therefore, that brings me to the end. So I hope you enjoyed the last 20 minutes. If you do have any questions or queries, my details are on the right-hand side under my contact details. But otherwise, I hope to speak to you soon on many other subjects soon. All the best.